and welcome to this demo on a new feature in Portworx Enterprise 2.12 called Scale-Out Object Storage. Scale-Out Object Storage allows us to use the Kubernetes platform to orchestrate our object storage buckets that we might need to run our containerized applications. Many AI and ML applications, among others, rely on persistent object storage, and Portworx is now providing a way to manage these object storage buckets right from Kubernetes. This is, of course, in addition to the block and file storage already provided through Portworx Enterprise. So let's take a look at how scale-out object storage works. First, this feature is currently supported for use with Amazon S3 or Pure Storage FlashBlade devices, but other solutions will be added in the future. Here we have Portworx Enterprise already installed in our Kubernetes cluster. As a user, I need to create a PX bucket class, which is pretty similar to a Kubernetes storage class, only in this case used for object storage. Next, we deploy a PX bucket claim, which, as you may have guessed, also matches pretty similarly to a Kubernetes persistent volume claim, again this time for object storage. When this bucket claim is created, Portworx Enterprise will provision your storage bucket with the solution defined in your class. Once the bucket is available, we need to create a PX bucket access object, which will create a secret on the Kubernetes cluster with the appropriate connection information for use with our applications. Let's see this in action. We'll create an Amazon S3 bucket through Portworx bucket claims, and then have an app use the connection info to do some work. First, we'll take a peek at the PX bucket class object before we deploy it. Notice that we need to specify the AWS region, and we needed to define some parameters about the S3 endpoint and the backend driver. We'll apply the bucket class so that we can use it. Next, let's look at a bucket claim manifest. Here, we specify the name of our bucket class we created in the previous step. When we apply this to our cluster, our bucket should be created for us. If we do a GET request on the object, we can see the bucket ID, and if we head over to our Amazon S3 console, we can search for our bucket that has that name, and here it is. Okay, that's neat, but let's keep going and create our bucket access. If we look at a bucket access manifest, you'll notice that we specify the PX bucket class and the PX bucket claim that were created, and we give our access a name. When we apply this PX bucket access object, we'll get a Kubernetes secret with our connection information in it. If we look at the details of this secret, you'll see all of our connection information encoded in base 64, of course. The last step is to deploy an application that can use this connection information for its own purposes. If you look at a simple deployment file I've created, I've added environment variables for the connection information, such as the S3 endpoint, S3 access and secret keys, and of course the bucket name. The deployment will read these environment variables from our Kubernetes secret so that they can be used by our sample application. Let's deploy the application into our Kubernetes cluster. Once the pods have started, we can then go check on the status and the pod logs just to make sure that it seems to be working okay. It shows that it's uploading files successfully, so let's take a peek back at our Amazon S3 bucket. As you would expect, the objects are being created in the bucket. And that's how simple it is to use object storage through Portworx Enterprise. If you're a GitOps shop that would prefer to manage object storage buckets for your apps through Kubernetes, then Portworx Enterprise has you covered. Thanks for watching.